Hello everyone, I'm Zhang from Chinese Academy of Sciences. The paper I will be presenting today is titled VQACL, a novel visual question answering continual learning setting, and this is a joint work with Professor Feifei Zhang and Changsheng. Our motivation is that the current offline learning does not meet the requirement of continuous multimodal data. In reality, data is often continuous and dynamically updated. That is, new types of questions or never-before-seen pictures are constantly appearing. So how to design a new learning setting for realistic scenes? This year's research on continual learning have recently led to a variety of work in unimodal community. However, little attention has been paid to multimodal tasks. Actually, in recent years, the volume of multimodal data have grown tremendously. For example, tens of millions of texts, images, and videos are uploaded to social media platforms every day, such as Facebook and Twitter. To cope with such constantly emerging real-world data, a practical AI system should be capable of continually learning from multimodal sources while elevating forgetting previously learned knowledge. In our work, we devote to the VQA task, which is a typical multimodal task and requires the model automatically generate a textual answer given a question and an image. However, it is not easy to set up a suitable continual learning setting for this task. First, the VQA input comes from both vision and linguistic modalities. Thus, the task setting should simultaneously tackle continuous data from both modalities in a holistic manner. Second, compositionality should also be considered in the VQA continual learning. The compositionality here denotes the model's generalization ability towards normal combinations of reasoning skills that question type and visual concepts that image object. As shown in figure, if the system have been trained with question type count with a variety of objects, like person and cat, as well as another question type what color about a new object track, then it is expected to answer a novel question like how many tracks are there. To achieve these two key points in this paper, we propose a novel generative VQA continual learning setting named VQACL. To solve the first issue, we design a door-level task sequence, where visual and textual data are nested. In the outer level, we set up a sequence of linguistic-driven tasks to evaluate models' ability for the ever-changing question types. For each outer-level task, we further construct a series of randomly ordered visual-driven subtasks according to image object categories in the inner level. Besides, to evaluate models' compositionality, we construct a novel composition spelt. As shown in figure, we remove a visual-driven subtask from each task in the outer level during training and utilize it for testing. In conclusion, on the one hand, our VQACL setting requires models to perform effective multimodal knowledge transfer from old tasks to new tasks while mitigating forgetting. On the other hand, the model should be capable of generalizing to novel compositions for cognitive reasoning. In VQACL, to enhance the model's compositionality, it is critical to learn an excellent representation that is discriminative for scene skills or concepts and is generalizable to novel skill concept compositions. Therefore, we propose a novel representation learning method. The architecture of our model is shown in figure, which adopts a transformer encoder-decoder network as the backbone and includes a prototype learning module. Besides, we also construct a memory buffer which stores randomly selected training examples from each past task. Specifically, given an image and a question from either the current task or memory, we first extract the visual embedding and the textual embedding. Then the embeddings are fed into a transformer encoder that stacks multiple self-addition layers to obtain the sample-specific feature for each modality. The transformer can encode the most attractive and silent content into the sample-specific feature to make it discriminative. In the prototype learning module, we learn and update prototypes of different question types and object classes. Since the prototype can aggregate typical category information that is robust to novel data, We select suitable visual and textual prototypes as the sample invariant feature based on the V and Q. Besides, updating the prototypes can help capture new typical knowledge while retaining historical experience, helping alleviate the forgetting problem. Finally, the vectors are combined and fed into the text decoder to generate the answer. A conventional negative likelihood loss is leveraged to optimize the whole network. Okay, during the experiment, we repurpose and evaluate 5 well-known continual learning methods. The results on standard test and novel composition test demonstrate the effectiveness of our proposed representation learning method. And the sensitive analysis on memory size and the qualitative results also show that our method always achieves the best performance and can successfully generalize to novel skill concept compositions. Finally, our contributions are threefold. First, we introduce a new continual learning setting, VQACL, to simulate real-world generative VQA. It can not only simultaneously tackle the continual multimodal data, but also can test models' compositionality for cognitive reasoning. Second, we propose a simple but effective representation learning method for continual VQA, which normally deploys a discriminative sample-specific feature and a generalizable sample invariant feature to reduce forgetting and enhance the model's composition ability. 3. We repurpose and evaluate 5 methods on our VQACL and observe that our model constantly achieves the best performance, demonstrating the effectiveness and the compositionality of our approach. Okay, my report is over, and thank you very much.